Yesterday I posted some work on numbers 1 and 2 on the worksheet. The work done for both number ones are pretty much consistent, okay? -4, 6, -3, 2. Very, very similar problems. Same thing with the number 2. The only difference is one of them is infinitely many solutions, or all real numbers, or -15 is equal to -15, 0 equals 0. Infinitely many. You could have even come out and said parallel lines. Okay, they're the same line, not parallel. Down here, when it came out to be -2 is equal to 9, there's no solution. Or 0 is equal to -11. No solution. It's not correct. So if you need, I'm going to post another worksheet on the substitution method later today, just for you to be able to practice on. Now, we're going to be working with the elimination method today, and I'm going to do an easy worksheet that's going to be posted in about a half an hour, not even, in about 20 minutes. And then I'm going to do a slightly more difficult worksheet posted later on today after a secondary lesson that I'll post a video on. Now, standard method, the setting up these equations in the standard form is going to be more effective. X's over X's, Y's over Y's, equal over equal, constant over constant. Now, can anybody see why it's nice that we line them up one over the top of each other? Can anybody see what could possibly be the reason? Okay, you're right. It's the 3's. In this case, if I line them up and I just add the 2 straight down, just combine them, okay? 2x minus 4x makes -2x. The -3y and the +3y, they cancel each other out. They're gone. I essentially get rid of one of the variables in a 2-variable problem and turn it into a 1-step equation. -5 and 1 make -4. Divide by a -2, and I get x is equal to 2. Okay? That's simple for 1/2 of this problem. All you had to do was line it up, and one of the numbers just naturally cancels out. Now, sometimes you may have to subtract. Sometimes you add. We're going to get down to some where you have to multiply, but right now, all you have to do is look at this. If they are lined up perfectly and you have to add straight down, subtract straight down, whatever it is, today's work that I'm handing out, the worksheet that you're getting today, is all fairly similar to this. Everything's lined up nice and neat, and something's going to wipe out. There's not going to be too much manipulation. There may be, I have to move a number over so that it is in standard form. And I'll do one of those in a second. But let's look at this. We're not done. We just have the x. Now it's your choice. Doesn't matter if it's the top one or the bottom one, to take the x and turn it into 2. So let's take the top one and make it a 2. 2 times 2 is 4. So you have 4 minus 3y is equal to -5. So you have to subtract the 4. So it's -3y is equal to -9. Divide by -3, and you should get y is equal to 3. So your ordered pair is 2, 3. You can't just go, cool, I got this one right. You've got to go, cool, I got to test to make sure I got this one right. So let's go up to the other equation. Change the x into a 2. Change the y into a 3. -4 times 2 is -8. 3 times 3 is 9. -8 plus 9 makes a +1. It did work. So your solution to this problem is is 2, 3. Now, what happens if they give you a problem that isn't lined up perfectly perfect? Like I said before, it may take some manipulating to line it up. Now, I've got a dirty workboard. Let me clean a board here real quick. Now, what do I mean by that? If you've got a problem that is written as a 2-variable equation, and then the other problem is written not in standard form, or neither of them are in standard form, it's always safe. Sorry about putting you in the dark there. It's always safe just to convert the problem that you've got into standard form. Okay, always easiest to convert it into standard form. What do I mean by that? Let's say I've got 4x plus n, or plus y is equal to negative 9. I'm copying this one off of a board. And then I've got negative 3y is equal to 4x plus 3. It is not lined up nice and neat in this problem. You've got things that are close. You could honestly start looking at this, and you may, as you get better with this, when you get a problem like this, you may look at this and go, you know what? It may be easier if I just move the 4x to the other side and make this a substitution problem and take that chunk and put it in the 4 for the y. You could do that, but the problem is they want us to do the elimination method with these. Specifically, when you're given problems where they say solve using the elimination method, you've got to do it. So you've got to move this so the x's are under the x's, the y's are under the y's, and the constants are constants. That means I've got to move this chunk right there over to the other side. Now, some of you are already looking at this and going, oh, cool, if I move that to the other side, it's going to become a negative 4x. That's correct. So let's rewrite this equation. If I bring this to the other side, it becomes a negative 4x minus 3y is equal to a positive 3. Okay? You see how I did that? All I did was this. Is it okay that I didn't show that little work right there? As you get further into the algebraic work, yes, you don't need to show every minute little detail as long as you're seeing, I took a 4x, I moved it to the other side of the equal sign, it's now a negative 4x. Okay? Most of your teachers are going to look at that. If you did what I did without showing it, they're going to look at it. If you do it right, they're going to go, okay, this kid's got their crap together. They understand it. They don't need to show every little piddly move. If you do it wrong, expect the teacher to go, show your work, because what you're doing doesn't make sense. Okay? It's not correct. It's not mathematically correct. But since I obviously know what I'm doing because I'm old, I moved the 4x to the other side and made it negative. Now, if you look at this, I'm going to pretend this isn't here. The 4x plus y is equal to negative 9. I just took this and wrote it above it. I just do that and make it a plus. I add all the way down. 4x minus 4x, you gone. 1y minus 3y is a negative 2y. Negative 9 and a positive 3 is a negative 6. And most of you can see this right now. Dividing by a negative 2, y should equal 3. Sorry, spastic there. Y should equal 3. It's your choice what one you want to do. I don't care. I personally probably would put the 3 up into the original bottom problem. Why? Because it's already isolated. And if I put a 3 in here, it actually turns into a negative 9 is equal to 4x plus 3. Subtract the 3, it becomes negative 12, and 4 divided by, or negative 12 divided by 4, x should equal negative 3. So your ordered pair should be negative 3, 3 when you work this one out. Test it. Put it in. Negative 3 in for the x. Positive 3 in for the y. Negative 3 times 4 is negative 12. Negative 12 plus 3 is negative 9. So it does work. Okay? That order, or that ordered pair does work for this equation. I will give you more examples later on the elimination method. The worksheet's going to be posted in a little bit. I'll do a couple more in a video later, but I will be moving on to elimination with multiplication or elimination with subtracting, which you'll see is like, oh, when you subtract, you blah, 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 blah. I'll show you some of those. Now, try the worksheet. If you get to parts of the elimination worksheet where you're like, I don't get the ask, send me. Some of you have been excellent about saying, I don't get number 3, show number 3. I'll do a little video for you, but then I'll probably steal that video and post it for everybody else a little bit later. I just have to tell you, some of you have been very good about asking the questions about problems and soliciting help. Quicker you get done with this work today, the better off we're going to be. I'll give you an idea right now, being that this is a long video, what we're doing the rest of the week. Today we're going to finish up the elimination method. Tomorrow we're going to review the substitution, elimination, all of this. You're going to take a test probably end of the day tomorrow or Thursday, covering graphing, equations, all of that first test, like a little bit of the things that I feel are important that you need to know from the first test. Then all of systems, working with graphing systems, the elimination method, elimination with multiplication, the substitution method. You're going to take a test on this stuff. And it's essentially second semester or first semester work for algebra. So we'll be done with all of first semester from algebra today, to this week. Then I'm going to post some videos for you to watch through the 4th of July week. There's no work that's going to be done and no time frame when you have to watch the videos, but it's videos of stuff that's going to be coming down the next week when we start working with quadratics and exponential work. It's ugly, people. It gets tough, and it is a 3-week course to cover an entire second semester where you're going to need to watch some stuff during the pre-week for our last 3 weeks, just to give you that extra knowledge so you can pass the final exam and get into geometry. So if you have any questions, I'm here. I'll be making videos. I can make more. I can always make more. I can make them different if you need something different. If you liked the big board got a little bit of a pain in the butt. It was tough. The big board was tough earlier simply because I wrote too big and I didn't use it the way I should. So let me know what you need. I'll talk to you later. Bye.